what they measured. If you want to know the measurements, it's in the article. But that's what they're showing, that secondhand smoke is lowering lung function based on their metric. What would the null hypothesis then be?
Secondhand smoke has no effect.
That it does, good, no effect. Can I say, I want to say it does not lower, if that's okay. Because it's exactly the opposite of what they're testing. I love what you say has no effect. But the trick is, it might raise it. In which case, let's all start smoking. Obviously, right? If we have that kind of goofy result, where everybody starts smoking and all of a sudden we can run marathons at 3:15, well, hell, let's start smoking. But that's not what we're testing. We're just trying to see if it lowers it, or does secondhand smoke does not lower lung function. The opposite of lower is does not lower. And it's a mathematical statement, but there are three things that can happen if you smoke and check lung function. Number one, it can do nothing. Number two, it can lower it. Number three, it can raise it. So if you're testing to see if it lowers it, the opposite of that is it does not lower it. This is one of those one-sided confidence intervals again, where you've got a red area off to the left, and you've got the whole gray-blue area off to the right. It's the same curve as the previous two, essentially. You're trying to see if it's changed it in a negative way. Now, let's talk about that p-value that's up there. I'm going to pull this down partially. Let's talk about that p-value of less than 0.05. What does that mean? The p-value is less. Did I give you a graph? I did not. We'll come back. We'll draw our own graph. Let's draw our own graph on that one. That p-value came back at less than 0.05, which is less than what? 0.05 is what?
5%.
5%. Okay, here we go. Draw a bell curve. Here we go. What's that, do you think? What's in the middle of that? This is the null curve. The null curve. What's in the middle of that?
0.
Is it good? Zero. I like that. Good. 0. What does 0 stand for in words? Baseline lung function. Thank you. This is baseline lung function. Now, I'm not saying baseline lung function is 0, you'd be dead. But I'm saying that it normalizes to 0. It's the average. Negative would be lowered lung function, positive would be upper. Okay, you ready? We smoke, we stick them in a room for an hour, we pull them out. So they land over here. What do we say? Somebody coughed, that was adorable. We put them over here, what do we say? Meh, yeah. Their lung function's a little down, but it might not be anything, it might just be a random fluctuation. Let's say the lung function comes back, it's over here. What do we say? We start smoking. We all start smoking because obviously lung function's increasing with smoking. Good, good, good. Okay? Now we're down here.
Yeah.
Okay, at what point, at some point it went from could you identify at what point it went from
5%.
Just tell me where it is. 5%. Well said, friends. Well said. Let's put it here, shall we? Let's put it there. There's your 5% region. 5% area. This, the middle part of this curve is baseline lung function. The middle percent, the middle, actual middle. This is elevated lung function. This is obviously reduced lung function. Reduced lung function down here. Could someone come up here and we're going to color code this. We're going to do at 0 hours after, and then we're going to do, let's use green, I haven't used green yet. 1 hour after. Could someone come up and place an asterisk where our data landed 0 hours after that secondhand smoke exposure? So in other words, these 16 Greek folks were stuck into a box filled with smoke for an hour. Then they were pulled out, and their lung function was measured right then. With the orange marker, could someone come on up here and place an asterisk at one place that could have been? You don't know exactly. Please, Linda, come on up. You don't know exactly where it is, but you know roughly where it is. Yes? Go ahead, Linda. Very nice, very nice. Good. Is it there at 0 hours? What would that mean if it was there? This is 0 hours after that exposure. So at 0 hours after the exposure, what was the p-value?
Less than 5%.
The p-value was less than 5%, so where does it have to be? It's got to be over here, doesn't it? Right, Linda, what you're telling me is 0 hours, baseline 0 hours. I'm talking about 0 hours after that exposure. This is where they were maybe at baseline, but hell yeah, they're over here now, and they're and they can't breathe, they're having a hard time, whatever the cytokines do. How about 1 hour after that? Linda's got to vote for it roughly the same place?
Yeah.
Oh, maybe even further? Here's the thing. Both of them just say less than 5%. I have no idea where they'd be. My gut feeling was that our bodies are pretty resilient, and if this is 0, my gut feeling is where would the next one be? I would guess it might be creeping back towards normal because our body starts trying to flush out the toxins. I have no idea though. So I'm going to put it next to the orange. All we know is it's down there. Natasha, go ahead.
It says at 3 hours it went back up, so you...
We haven't gotten there yet. Thank you, sister. Good. Good for you. Good for you. So, so logically, 0 to 1 should be on its way. Thank you. Thank you. And then it makes me question, why did they pick 0 and 1? How about like 0, 1 and a half? At what time did it actually cross that threshold? I don't know. I don't know because I don't speak Greek, and I can't ask them. So now, we know that these two, 0 hours, so in other words, an hour of exposure led to decreased lung function, and even waiting an hour past that, it still decreased. But then what happens? What happens then? I'm going to skip ahead. We skip ahead. At 3 hours, they were, now they've got to be careful with this statement, at baseline levels. Now when you read that from a non-statistical point of view, that makes it sound like it landed directly in the middle of the curve, yes? I guarantee it didn't land directly in the middle of the curve. So this is 3 hours after. Where is it?
Probably just to the right of 5.
Sure, it's somewhere in the interval of baseline. So, and again, Natasha, this is your binomial. It's either at baseline or it's not. We're back at baseline, we're in the interval somewhere. If you put it here, I'm a happy guy. If you put it here, I'm a happy guy. If you put it here, I'm a happy guy. It means you understand what a big p-value means. That's what I'm after right now. So in other words, it appears that time actually has a factor in secondhand smoke flushing from the lungs. That's what this is kind of getting at, time. Now you can micromanage that even more with successive studies, obviously. You can actually go back and look at, okay, let's look at 10-minute intervals and see if it actually is, as Natasha said, like a linear or some kind of exponential increase in lung function. Good, I don't know, I don't have an answer for that one. Again, don't speak Greek, haven't followed up with the authors. Ask me that question, Linda.
So is the study trying to say that after the first hour that it affects you, and after that, if I understand this right, then it basically you go back to normal?
Well, I don't know how long after the 1, between the 1 and the 3, normal is.
But they're still being exposed.
Right. What I'd also like to see as a follow-up, I can't answer that question because I don't know, because that's not the study. The study just wanted to see if secondhand smoke does indeed knock down lung function. And it looks like it does. What I'd like to see additionally is, does repeated secondhand smoke exposure lower baseline? That's what I'd like to see, yeah? Because like I said, I'm interested mostly because it happened for 4 years, or 2.5 years, and actually the law changed halfway through. You should say, oh, pissed off punk rockers. Oh, there's smoke outside? Yes. It's still 28 degrees out there? Yes. Have a good time. You have a cigarette, you're warm. So that's why I want to see if baseline actually creeps down as repeated secondhand smoke exposure happens. However, this study didn't do that. It just did one block of 16 people. Fair? Yeah. Now, I didn't bother in this one, oh, sorry, Caitlin. I didn't bother in this one restating the hypotheses because the hypotheses are the same. The only difference in the hypotheses is what time element or what time increment are you testing?